Week 15, lesson 4. Okay, so on the paper that's in front of you, either on the screen or on your desk or wherever you're doing this, you'll see a chart that I would like you to fill in. So I'm going to do, some of it with you, and then I'm going to ask you to pause the video, try to fill in the rest yourself, and then check your answers. Okay, so let's start with the top row. Okay, top row. This is a complex number. All right, just a reminder, the complex numbers are of the form a plus bi. So for this one, if I wanted it completely in complex form, it would be -3 plus 0i. All right, and just a reminder also, because this will come in handy on the other ones, I know how to graph that. Remember, this is the real axis and this is the imaginary. So this particular number, this complex number, is right here at -3. Okay, so that being said, this is just asking you to find the reciprocal, which would be -1/3. This notation is asking you to find the radius. It's called the modulus. Okay, in other words, how far away from 0 is that particular dot? So this is asking of the original, which is 3. This is asking for the modulus, or the radius of the reciprocal of this number, so that's 1/3. Notice that they're positive. All right, and then this notation is asking for the angle. Okay, so what angle does it make? And again, you are coming from this particular line. So for -3, it's asking how far away is that? That would be pi. All right, and then for the argument, right, the argument, again, if you graphed that, it is also pi. All right, so this is where I would like you to pause the video, see if you can fill it in, and then come back and check your answers. And I'm hoping that you were able to get these values. Now, the reason that we're doing this is so that you will see that these two columns are reciprocals of each other. Oh, that's not the right pen. Let's try that again. Reciprocals. All right, and I'm hoping that you're seeing that these two columns, those angles, right, column 1 plus column 2, have a sum of 2 pi. Okay, a sum of 2 pi. Okay, because this is going to come in really, really handy when we decide to take the reciprocal of numbers that are in complex form. Okay, so if you, and here's kind of the definition that you're seeing. If I can move this, here we go. You're going to be given a number. I hate it when I don't have the right pen. There we go. You're going to be given a number in complex form. So step 1, you're going to have to change it to polar form. Okay, and you are going to be finding the reciprocal, right? So here is the entire formula that you need. Okay, the formula. Notice that you're trying to take, you'll have to take the reciprocal of the radius along with doing 2 pi minus whatever the angle is you have here. Okay, so I have one example that I'm going to do with you, and then you'll be doing the worksheet. Okay, so here's the directions. Find the reciprocal of the given number, 1 by using the formula, and 2 by writing it in Cartesian form and taking the reciprocal. All right, so here we go. Excuse me. So here is our complex number, and notice it's already in polar form. So let me write that down. Z equals 2 cosine I sine of pi over 3. Okay, so for the formula, if I'm going to do 1 over z, right, I'm looking up here, I need to do the reciprocal of the radius, and then in the parentheses I have 2 pi minus the angle. In other words, 2 pi minus pi over 3. So that's 1/2 cosine I sine of 5 pi over 3. All right, which, let's see, that ordered pair is 1/2 negative rad 3 over 2. Okay, and then don't forget, like if you expand this out, you have to distribute the 1/2. So you get 1/4 minus rad 3 over 2 I. Okay, so now to do it the other way, right, which is to write the number in Cartesian form. Let me draw a picture of what this looks like. I have an angle of pi over 3. Just a reminder, that's 60 degrees. And a radius of 2. All right, so because this is a special triangle, I know that this side is 1 and this is rad 3. So that means in Cartesian form, my point is 1 plus rad 3I. So then I'm going to take the reciprocal of that. So 1 over 1 plus rad 3I, which then has to be rationalized. 1 minus rad 3I. The top is easy because you're multiplying by 1. And the bottom, when you FOIL, first term is 1, the inners and the outers cancel out. The last term is negative 3I squared, in other words, plus 3. So the denominator is 4. And I just realized I'm looking back at my answer to double check. I wrote the wrong number here, you guys. That should be a 4. All right, there you go.